All right, so here we got this kind of graph, r equals 3 minus cosine. So this is not quite a cardioid, but it's very similar. It's called a limison, and I didn't make up a big category about it. So it's very similar to a cardioid, and let's just kind of investigate these points to see what it looks like. And again, finding out the points that it's at the origin are crucial. So if I plug in angle 0, I get 3 minus 1, so that gives me r equal 2. If I plug in theta is pi over 2, I get 3. If I plug in pi, I get 4. 3 pi over 2, I get 3. And angle 2 pi, I'll get r equal 2. So let's go figure out what this looks like. So angle 0, I go at a distance of 2. Angle pi over 2, oops, I said I did that wrong, didn't I? No, that's right. I go at a distance of 3. Angle pi, I go at a distance of 4. And angle 3 pi over 2, I go at a distance of 3. And then back to 2 again. All right, so let me put the 2 there so you can see it. There are no points at the origin. There are none. It's a dented heart, so the pinch of the heart, it does not go into the origin. There are no values where r equals 0, right? So when these numbers are not the same, then you won't get a point that goes into the origin. All right, let's look at r equals 3 sine theta. Remember, this is one that just takes 0 to pi to go all the way around. So in angle 0, you get r equals 0. Pi over 4, you would get 3 times root 2 over 2. Angle pi over 2, you would get 3. Angle 3 pi over 4, you would get 3 times root 2 over 2. And angle pi, you'd get 0 again. All right, so let's look at what we've got. So this is angle 0, that's at r equals 0. Angle pi over 4, we would get 3 times root 2 over 2. Angle pi, I'd go all the way up to 3. Angle 3 pi over 4, I get 3 times root 2 over 2 again. And here would be angle pi. So this has 2 angles at the origin, right? Angle 0 and angle pi both give me r equals 0. R equals 0, distance out means you're at the origin. So again, here I have a dented heart called a limison. These numbers are not the same. So let's go figure out what they are. So if I plug in angle 0, I get r equals 3. Angle pi over 2, I get r equals 5. Angle pi, get r equals 3 again. Here I would get r equal 1, and then this would give me 3. All right, so let's graph this. Angle 0, I'm up to 3. Pi over 2, I'm up here at 5. Angle pi, I'm out here at 3. 3 pi over 2, I'm here at 1. So since I know it's a dented heart, there it is. There are no points at the origin, right? This is one of those dented hearts, then since these numbers are not the same. Okay, so we did this already, but let's go through and just graph some of these points so you can see where they are. So this is a 2 theta, so that means I know I'm going to have 4 petals. And since it's the graph of sine, I know it's going to be symmetric with the y-axis. So if I plug in 0, I get 0. If I plug in pi over 4, that gives me sine of pi over 2, so that's 1. If I plug in pi over 2, that gives me r equals 0. So theta 3 pi over 4, so that's sine of 3 pi over 2, so that's negative 1. This gives me r equals 0 again. So let's stop here and see what I've got. Angle 0, I'm at r equals 0. So angle 0 gives me r equals 0. Angle pi over 4, I'm at 1. Angle pi over 2, I'm back to r equals 0. So here to here, right? Okay. So then I'm moving to r equals 3 pi over 4, and I go a distance of r equal negative 1, so that means opposite direction, distance of 1. Angle pi, which is here, I'm back to 0 again. So it traces out a petal like this. So angle 5 pi over 4, which is like 5 pi over 2, which is r equal -1. Hold on a second. 5 pi, it's like pi over 2. Sorry, it's +1. Then angle 3 pi over 2, which would be like 3 pi, that'd be 0 again. And this would be 7 pi over 2, so this would be a -1. Okay, here we go. So 5 pi over 4 is over here, so that's going out a distance of 1, back to 0. So from 0 out to 0. Angle 7 pi over 4, which would be down here, out a distance of 1. So there's my 4 petals. So I got an angle of pi, giving me r equals 0, and an angle of 3 pi over 2, giving me an r equals 0.